Hello and welcome back to another tutorial on this channel. In the last tutorial I showed you how you can combine these meshes so you just have 3 instead of over 4,000 blocks when creating some kind of Perlin noise map. But you see the border here is missing, and in this tutorial we're gonna tackle that. So let's don't waste any time and dive right into it. We're back in code in our old mesh generator from the last tutorial. If you missed that, then I'll create a link to that in the top right corner or in the video description. And we're gonna extend our code a bit further to have these cool world borders. But first we want to give another parameter into this function, which is the map size. So we get the vector2int of the map size right in here. And now there is an error, so we're going to fix it by simply passing over our map size. Why is this important? Because we do want to check, okay, if we are at the end of the map size, so we're checking if the tile is at the border. So in our case, we have 64 by 64. And if our tile is at 63, because it's null based, then we know, okay, we are at the border. Please generate a mesh down. So let's tackle that by simply staying within this loop, because we do want this for each child object within our mesh parent. And I just create a comment so we know, okay, here starts the code for the world borders. We have the float top, which is 0, and we have the float bottom, which is -1. This simply are just constants because we want to say, okay, 0 is our current position and -1 is the height of this block. So I just call it bottom. You also can call it height or something like that, but I stay with bottom because this simply is the bottom of this triangle. So, and now we have to tackle 4 cases. If the x is 0, if the set is 0, if the x is the map size, or if the set is the map size. And if one of these 4 cases is true, then we want to generate our vertices and add it to our vertices list. So let's start by just checking the x is equal to 0. Because x is a float, we want to make sure that we cast this to an integer, because the map size is vector2int, and we want to compare it against that later on. So we have the x check, we have the set check, and then later on we want to check if the integer of x is equal the map size dot x but -1, right? Because this whole thing is null based, and we want to check the exact same for the set later on, but for the y, because unfortunately this is a vector2int, not a vector3, that we can use the set axis to check if we are at the end. So these 4 cases are for the 4 borders we have within our map. So now the hard part comes, which is actually kind of difficult to explain, but I'm trying my best that you get the gist of it on how this whole thing works. We're just creating 4 vector3 variables which act as our vertices, but we have to have in mind which direction we're tackling, because this is important, because we want to have our mesh only be visible from one side to really stay performant, right? Also, this is pretty important to check because we do really want to be at the edge and not one block before that, right? So just follow me to get the correct values. Unfortunately, we already have the A, B, C, and D variable right here. Therefore, I just go with the continuing alphabet like E, F, G, H. So we have the vector3 E equals new vector3, which is the x minus 0.5. Then we want to start at the top, so 0. And then we want to have the set plus 0.5f. So we currently start at the top left corner, and now we want to choose the f variable to be on the top right corner. Therefore, we're just subtracting this one. And actually, we can copy these 2 because we still want to be on the left and on the right corner, but we want to stay at the bottom now. So we have these variables not flat like in the example before, where we stay on just one height, but we want to do the same as here, but we want to go vertically. So we just rename these to G and H. And instead of the V we already have here, we take a J. So let's create a new vector 3 array called J, which is a new vector 3 array. But we want to fill it with new vertices. And now we want to make sure that we get the correct order for that. So we want to have the E, the F, the G for our first triangle, followed by the triangle FHG. So I'm gonna explain this right away. We have again this kind of field. This is just a cube, I'd say. Something like this. And in the code before, in the tutorial before, we covered this area. That's why this is on 0. And now we're tackling this one. So because this is 0, this has to be -1. And actually this is the really same outcome as last time, where we have the A, B, C, D here in front, here at the top. And here we have the E, F, beautiful, G and H that we want to tackle now. Of course, this is just one side of the cube or of our whole map, because we have 4 sides. We have this side, we have this side, we have the side in the back, and we have this side on the left. So we have 4 sides, so we have 4 different calculations. And as this plane here, this plane side here, as a front and a back side, we have in summary 2 different orders we have to manage within our vector array. So with this explanation, we have our first order right here, EFG, FHG, and we already can start by adding these vertices and our triangles to our tris and to our vertices. This is the exact same code as we already have done in the last tutorial, to just add the pointer for the triangles and to add the vertices. So this is exactly the same, just that we use a J variable for this order. I can spoiler you right away, because we're checking here for null or 0 and checking here for 0. We can use this code twice, because these both are the same order, because it will show us the same surface, the front surface. However, the calculations are a bit different here. We can still copy it, but we have to make sure that we arrange them accordingly, because now our set is the base value we're checking. So we want to subtract everything from set, but want to add something to the x value, because we have now the other side of the cube, or of the whole map if you want it that way. So this is our current code. We can have a look on how this is looking in Unity. So you see there already is a border here and also here, but interestingly, when we're going from the back, you won't see anything of this border right here, and also you won't see anything of our surface on the top. This is pretty cool to save some resources, and here's a little hole, but we're gonna fix that later. But you see there already is some kind of border. And now with this validation, we can easily create the other things. And as you have already guessed it, I think, this is just an inverted calculation from this one. Because you see here we now subtracting everything from x, and here we are subtracting everything from z. And wow, it turns out we're gonna have to go vice versa. We now have to add something to x and add something to z. So let's don't waste any time and do it right here. We're just copying this, because it really would be dumb to write it myself. I'm really lazy today. So let's just add everything to the plus, because the set calculation still is the same. What indeed is different is the order. As I mentioned, we have 2 different orderings for these, and instead of having E, F, G, F, H, G, we're having now a different order, which is E, G, F, F, G, H. This is, as I already explained within MS Paint, because we're now at a different angle and want our front surface to be looking to the camera or away from the object, so it's visible from the front side. If we would take this order, then you only would see the back side of it, which kind of destroys the illusion that this is a complete block, right? And as always, we want to add these to the vertices and to the triangles. And now we can copy this whole thing. I want to make sure that everything gets added to the Z axis and vice versa. It gets subtracted from the X. So this is the complete code for the last side. But before switching to the Unity editor, we want to fix the error that there was a little hole within the border, and this is easily because we have an else if here. This should be a normal if, because on these corners, both of these scenarios can happen. So we're just removing the else here and are good to go. And here we go. As you can see, there is already a border on each side. We can rotate this little island and you see everywhere is a pretty cool border. And as I already showed you before, this is flipped now. We can see nothing. So this is pretty cool. We can already see where these borders are, and this is saving us a lot of resources, and I think this is pretty cool that way. In the next video I will show you how you can also apply this not only to the border but also to every block that is within this island. For example, if now the water is at -1 and the grass is at 1, then I'll show you how you also can get rid of these empty spaces here and have also some edge meshes. So if you liked the video, then please hit the like button, comment down below what I can do next, and if you like this tutorial or want to join me on my journey on creating some games, then please hit the subscribe button. Thanks for watching, see us in the next video, bye!